We went on the break. We saw um, what .NET Framework is. We saw what .NET Core is. We saw the difference between the .NET Framework itself and the C Sharp. So .NET is a framework. C Sharp is a programming language. The framework sits on top of an operating system. It is specific to the operating system. And on top of this, we run our executables and DLLs. To create these, to run these DLLs, we use CLR, and then to build these EXEs and DLLs, we use the SDK. As a developer, we are going to have different SDKs installed based on the framework or um, the the platform that we want to build our code for. We're going to have the appropriate SDK installed. C# is a programming language. It has its own syntax and semantics. And in using these semantics, we are going to create those programs and applications. We saw how the CS_proj file for .NET Framework project is different than the CS_proj for the .NET Core projects. And then we saw how their assembly references and project references, they look a little different. Now, before the break, we were talking about as we add function to a class, that function gets a shared copy, and that copy is shared across all the objects. Creating objects is going to have a dual effect. Part of it is going to go in stack. Most of it, the actual memory of it, is going to go in the data segment. And when the function is called for that particular object, it is going to internally figure out which object is calling it and what memory locations to reference using a keyword called this. And through this, it is going to reference the correct object and modify the memory in the data segment for it. And it is going to perform whatever operation that we are programming it for. With that said, the concept that I want to highlight at this point is that the way we have addresses assigned to all these locations. So suppose this starts at 0x00 and it goes to 1 MB or probably 64 KB all the way up to FF. Every location in the code is going to have a memory, right? Including this ID field. I'm just going to assume that it is 0x200. If I want to modify this ID using computer program, all I have to do is I have to access this memory location. And on this memory location, I have to execute instructions like move and add. Whatever data is getting referenced at this point is going to get modified, right? And this is the general concept of pointer. Now, a pointer is an address, like simply put. Now, because address is dependent on the memory that the CPU can address, it is going to be, say, 16-bit for processors like 8086. It is going to be 32-bit for processors above 386, right? So I'm going to call it x86, but then it is an address. A character can have an address, an integer can have an address, a float can have an address. Because address is the location, the size of all these data types, and a character pointer, integer pointer, a float pointer, it is always going to be the size of the address, which is 4 bytes. But then functions and memory locations inside code, they can have addresses too, right? So if I declare a function called logger inside the C# class, this logger function itself is going to have some address. And say if this is series 200, I can put it in the series of 100. And then this can be the address of logger. The way I can declare a character pointer, I can also declare a function pointer. And then size of function pointer, once again, is going to be 4 bytes because a pointer stores address, and address is 4 bytes in most processors that we have. If we can modify a memory location by telling it that go to this address and save 20, or go to this address and add 1 to it, right? we should be allowed to perform similar operation on function. Now, because function is not data, we cannot have instruction like move and add or an address for function, but we can have instructions like call and then give it an address. And this is the entire concept of pointers, that pointers are addresses. If you provide that address, you can perform operation on it. Functions can have function pointer too, and function pointer is going to point to the code segment. So it is a memory location from the code segment, and the operation that you can perform on function pointers is that you can call them. The way we are going to use this is, okay, we're going to start with something simple. I'm going to get rid of most of this code. And over here, if I don't want to keep using the static keyword because static causes a lot of confusion. So I'm going to hit a short key, Shift, Alt, and C. You're going to see me do that a lot. It pops open, add new item, and specifically selects class. I'm going to hit app, hit enter, and it is going to create a class for me. Now, to add a function to it, I'm going to say public void run. And from this point onwards, like in 90% of the cases, I am simply going to say var app, assign to new app, and I'm going to go do app.run. Most of the programming that we're going to do in the rest of our course is going to follow this structure that I'm going to create a new class called app and add a function called run inside it. Over here, I can call multiple functions, add 10, 20. Now this function does not exist, but then there's a red squiggly and there is a little light bulb here. One of the Visual Studio features. I'm going to select this and I'm going to say generate method app.add, and it is also showing me the body of that code, what that code is going to look like. An easier way to access this thing is I can come here and hit control dot and choose the first option, hit enter, and it has provisioned that function for me. Okay. I'm going to leave this. I'm going to delete this throw statement and leave everything as is. I can define a function for subtract the same way. I want to subtract 10 from 20. I'm going to hit this and delete the throw statement. Now, as we are adding these functions to the app class, it has three functions: run, add, and subtract. This code is going to get converted into assembly language. If I can copy this and go back to our whiteboard, I'm going to paste it here. It's going to give me an option of drawing. Right? This statement is going to translate to a call statement, and it is going to put an address over here. Right? Say that address is 100. For this statement, it is going to once again translate to a call statement and say this is address 200. Now, when this thing becomes an exe, the exe probably is going to start at say 0x00 and I'm just making these numbers up, and it's going to end at 400. This thing probably starts at 50. Right? When we run our application, it is going to be a series of call statements like 0x50, and it is going to call the run function. When it goes inside the run function, it is going to see call statement for 100, and it is going to this add function. The add function over here starts with 100. It is going to do its multiple operations, and it is going to return back. What function pointers are going to do is they are going to save this address in a variable. So the way we declare an integer variable, integer I assigned to 10, this thing gets a spot in the data segment, right? I can declare a special syntax. In C programming, it is called function pointer, and I'm going to declare it, say, P math operation, pointer to something for mathematics. And over here, instead of 10, I'm going to put the add keyword, right? When the compiler sees a statement like this, it understands that add function from the code is something that we would want to assign to this variable. So in the data segment, the address of I was getting 10. In the code, it is going to look very similar. It is going to be move instruction, but then this time it is not going to be a value. It is going to be address of the function itself. Now, the way this call statement is executed, we are going to execute another call statement, but this time we are not going to put add. We are going to put the variable name itself. So the way we were doing, say, add I and 1, so it will add 1 to I. We are going to see the math pointer or a pointer for mathematical functions with a call statement. And then this statement is going to say that whatever information you have in this variable, please go ahead and call that function. So the way I is declared on data segment, the p math is also going to get declared on the data segment. And the value that is going to store is the address of the add function from the code segment. Integer variables can have arithmetic operation like add, and you can provide it parameters and then mention the variable in the square block in the square bracket here like this. You can have similar instruction for this particular thing, but then because this is a different data type, it is a function pointer. We cannot use add. We'll have to use something like call. And then call is going to take this location, and whatever it is pointing to, it is going to call that particular function. So a function pointer is a lot like a variable. It goes and sits on the data segment, stack segment, depending on how you're declaring it. And the value that you assign to it, the way we have arithmetic operation for integer, we can have call operation for that particular address. The advantage that we get is we can introduce some form of dynamic behavior to the application. The way I assign 10 to I can also assign 20 and perform the same operation. The way I assign add function to this, exactly the same way I can assign the subtract function to this. Through this, we have defined a new data type, which has probably the same storage mechanism, but a different set of operation. We are not going to perform arithmetic operation. We are going to perform code level operation, and code level operation is called. So depending on what function address you are assigning to this particular variable, that function is going to get called when you have this statement defined, when this statement executes. So this is function pointers in the C programming language. C sharp, it does not have pointers, but then it has another data structure, and that data structure is called delegate. So if I have to define a delegate, now I generally get confused in the syntax, but then I'm still going to attempt. The delegate syntax looks exactly like the function. So I'm going to copy this and I'm going to paste it here. I'm going to hit the closing a semicolon. So delegate starts with the keyword delegate, and then it has the same signature of the function with which you want to point it. So because it has a return type void, I'm going to put void, and then the function name, I'm going to leave it as is. I'm going to change it very quick, and then it is going to take the parameters that those functions are supposed to take. I don't like using delegate name same as the function name. I would want to use something generic. And then if you remember our example from yesterday, which is common noun and proper noun, add is a proper noun. The common noun for this is a math operation, right? Or if I want to be more specific, I would say binary operation. A binary operation is going to take two parameters and it's going to perform operation. Then if you want to keep it easy, let's just keep it math. Now we were able to call these add functions, and I don't have to show this to you that how these functions are getting called, but we're going to change our program a little this time. I'm going to delete these two statements. I'll probably just comment out for comparison. And I'm going to define the variable math. I'm going to call it operation assigned to add. Makes sense? And the way to call that is operation. I'm going to pass 10 and 20. Let's go ahead and complete this function. Over here, I'm going to say console.writeLine and v1 plus v2. Now, if I run this program, it is going to print 20. I'm so sorry. It's going to print 30. 10 plus 20 is 30. It's going to print 30. No surprises there. The advantage that we get is we can change this value to subtract very easily, and subtract is going to execute this, and this time we should see -10, and -10 is here, right? I'm going to go back to our discussion. The way we declare variable, right? This variable is going to get, this variable integer I is going to get defined, and it is going to have some value in it. So this variable itself goes and sits in the data segment. This value gets modified and assigned using the code that we are writing, the assign statements. We can define similar data types as integers and characters and floats. And then that data type is called a function pointer. A function pointer in C is defined with a special syntax, function something. We don't have to know that syntax for our discussion, but then like declaring any other variable, we can declare a variable that can store the address of a function, because functions are special spots in the RAM. The way data segment have different addresses and our objects are sitting there, our functions are sitting in the code segment, and they have addresses too. If we can figure out a way of storing those addresses in a variable with any special syntax, any special data type, we can save those addresses, and then the way we perform arithmetic operations on integer and float variables, we can perform function level operations on these addresses. Function level operation is called, so we can call these functions, and then whatever place it is pointing to, it is going to pick up that data and it is going to call that data. So through statements like these, we are defining a new data type, and then this data type can store addresses of function, and then this can change at runtime. So now I can once again come here and assign operation assigned to add, and I can repeat this line. And now if I run it, we're going to see two output. The first for subtract, the second for addition, add, right? What we have essentially done is we have told it that save the address of this particular function and call that function. Save the address of this function and call this function. Now, I hope this concept is clear to you, but we don't have to restrict ourselves to integer types. And then for this, we saw another example yesterday, and that example was through generics. What I'm going to do is for every type that I have, I'm going to define a parameter over here. And I'm going to start with t. You can have absolutely any name like we saw yesterday. I'm going to replace this int with t. OK, now I have defined a generic implementation of this new data type, which can take any type parameter. It is complaining that it doesn't know how to initiate this thing because through subtract, it is not able to identify the type. And to define that, I'm going to hard code the type over here to integer. Because I know that subtract is taking integer, it is fine to have uh, integer mentioned over here. And this integer is by the compiler going to get replaced by this t parameter, and you will once again be allowed to assign these variables to it. OK, so these are in summary delegates for you. Right. You can go ahead and define these multiple types, but then this really doesn't is not the efficient use. Uh, if you remember our discussion from CLR or the library work, a framework generally has two parts to it. So far, we were looking at CLR, the common language runtime, but then there's something called as base class library. A base class library is going to give you multiple implementations of a lot of code. So console.writeLine is an assembly that probably comes from the base class library itself. For delegates, there is a special implementation from the C# programming language, and it is called there are three variants of it. One is called action. The second is called Func, Func, and the last is predicate. So we're going to see example of all three. Uh, Let's go ahead and declare an action. So this action is exactly like this math variable over here. All I have to do is I have to assign the int type. I can say integer. I can call it a math action. And once again, I can assign the add function to it. Now it is complaining, it is saying that no overload of match takes two integers, takes an integer. The problem is that add function is taking two parameters and the action that we are doing is defined only for one. So let me go ahead and press F12 over here, go to definition, and it is taking a function that has one parameter. We want a variant that takes two parameters. And the way to do that is by adding another variable to this list. Now, if I go to this definition, you will see that it is taking two arguments, argument one and argument two, right? So with this, we don't have to define delegate ourselves. An action is a built-in delegate. Let me go ahead and hit F12 one more time and notice that the return type of an action is void. Okay, everything that we accomplished using the math delegate that we defined, we can do using the action delegate as well. So for action, we have used math action, and let's go ahead and comment out the operation code. And I'm going to use the math action, which is this variable, and I'm going to pass 10 and 20 to this math function because it is pointing to add. If I execute this code, it is eventually going to run this particular code. And once again, no surprises because math action is assigned to add function 10 plus 20. Add function got executed and we got the result 30. Make sense? There will be scenarios where you would want to return some data. So let's go ahead and add a multiply function. And then multiply function is probably going to return um, the result instead of printing on console. And then over here, I'm going to say X and integer Y. I'm simply going to say return X into Y. All right, nothing fancy over here. Once again, this multiply function is taking two parameters, and then we should be able to use this variant of the math function and assign it to multiply. All right, this is going to complain because the signature is not matching. All right, multiply, it is saying that it has a wrong return type value. Correct? So we will not be able to use action this time. We'll have to use another implementation, which is Func. Now, if I hit F12, you're going to see that it requires at least one parameter, which is of type tResult. We saw something similar yesterday. If you want to return something from the function or a generic type, you can reference that over here. So with this parameter, you can influence the return type of this. So I'm going to specify the return type as integer, but this thing is also going to take two parameters. So I will have to first provide those two parameters, and the last parameter is going to be the return type that we want. And then I'm here going to say func operation. And to this, I can assign the multiply function. All right, let's go ahead, hit F12 and try to analyze this definition. So this is once again delegate. We declared our delegate with a delegate keyword, then the return type, the name of the delegate itself, and the list of parameters that it is going to take, and then the function definition itself. Because we are passing two parameters, we are going to take two arguments. And because we are returning a type, we are going to put the return type over here. All right, so func is going to get assigned like this. And now I can do func operation and pass 10, 20. And I'm going to save the result with the var keyword. And over here, I'm going to print the result. Now, if I hit Control F5, it is going to print 200. So 30 is for the previous operation and 200 is for the func operation. Make sense? So what we have essentially done is instead of defining delegate ourselves, which are type bound and which have restrictions, we have gone ahead and started relying on something available from the base class library, which is Func and action. I'm going to comment this out. I'm going to comment this out. So Func is going to have a return type. A return type is always going to be in the end. So just to see a better example of that, let's have a string return type from a function called say hello, and this is going to take an integer variable, say x, and over here I'm going to say return. This is a different syntax. You put the dollar sign and double quote inside it, and over here you can say hello, comma x, and then to access the variable, we'll have to put it inside curly braces, right? So we can replace the value of variable inside a string constant, and then we'll have to put a dollar keyword in the beginning. I can assign this say hello to a function to a func that takes like one parameter. To define that, I'll have to declare a func over here. This func is going to take an integer, which is x, and it is going to have a return type of string. And I'm going to say message and assign say hello to it. And the way I'm going to call it is message, and I'm going to pass say 10. And this is going to be our output. And let's just print that output on the console. I'm going to comment out this code, and let's just run this example. So this example is pointing to the say hello function. Say hello takes an integer and returns a string. The input becomes the first parameter. The output becomes the last parameter inside a func delegate, which is um, from the base class library, and this becomes the name of it, and we can call it with this particular variable name, and it is going to take this parameter, return this message. And now if we execute it, it's going to say hello 10, right? So we can play around with the data types and create a definition of these delegates from CLR and execute those through these statements. The last variant is I think I sometimes feel that it is an overload of the func. If I want to return a Boolean over here, right, and instead of say hello, if I want to have a function that says is not 0, all right, I'm not sure what happened. All right. So I'm going to define a new function, bool. All right, my computer is pulling up random screens. I'm not sure what happened. I'm probably going to have to drop off and join again. Give me 1 minute. All right, I'm sorry about that. So what we have done is we have defined a new func that takes one parameter, which is integer, and then it returns a Boolean. And we are going to assign it to a different function is not 0. And then is not 0 is going to take an integer here. And it is simply going to compare x not equal to 0. not equal to 0. And whatever is the result of this operation is going to get returned in the form of bool, and it is going to sit here. Now, if I can call it compare, and if I hit Control F5, it's going to return false. Okay, I'm so sorry. It's going to return true because it is not 0. Predicate is a lot like Func that only returns a Boolean and it only takes one parameter. So the third variant in this series is predicate. It takes, we're going to define a predicate that takes an integer, and I'm going to say compare. And once again, I'm going to assign is not 0. The rest of the code can look exactly the same. So let's just go ahead and copy, paste, and uncomment this. Right. So if I run this, let's see the output first, and then we're going to jump into predicate. This is going to show true because 10 once again is not 0. So what we have essentially seen in this entire example is that we have defined a new data type. The data type is going to store function addresses inside them. And then because it is going to store function addresses, part of the definition of this variable is going to look like the signature of the function itself, including the parameter it takes and the return type of the function itself. Then we use this math class and defined our own operation. And then we assigned it to add and subtract function. And then I called it using the operation variable. So we are not calling using add and subtract function themselves. We are using a variable, and to that variable, we are passing the parameters that we would have passed to the add function and subtract function, like here in these two lines. We are not using the function name directly. We are assigning function name to a memory location, and then we are calling that memory location. But we don't have to define these delegates ourselves. We can rely on three options that are available to us from the framework. Those options are action, func, and predicate, or func, action, and predicate. The difference between these three is that action is always going to have a return type of void, right? Func is always going to have a return type as the last generic member, which is the result. And predicate is a little different. Predicate is definitely going to have the Boolean return type, and it'll take only one argument. Now with this, let's jump back to ILSpy, and over here, I'm going to show you the search capabilities. If I come here and type func func, and there are multiple options available over here. I generally set it to type or method. So this time we have set it to type, and then type is coming back with these results. And notice that it is func. It has a little briefcase indicating that it's a delegate. And if I double click on this and switch to C# language, the syntax itself is going to look like this, that it takes only one generic argument, which is of t-result type. Ignore this out keyword here. And then this t-result is mentioned as the return type, and it does not take any argument. There are multiple other variants. Notice that there's a little tick sign here, and then number 1. It means that it has one template argument or generic argument. If I select func10, double click on it, okay, and I'm going to just select it from here. So notice that this is func of 2. It is taking t and t result. T result is mentioned here, and t is used as this argument. We had seen two argument variants of this, t1 and t2. T1 is argument 1, t2 is argument 2, and t result is the return type. And then func has about 8 overloads, right? So you can define multiple generic arguments over here with one last return argument. Return argument goes and sits here, and those generic arguments, they become part of function. So if you have a function which takes 8 parameters, you can use this implementation of Func and you can call it using delegates. The same way, it is available for action as well. If I click on action, go here, notice that action also has about 8 variants, and all of these variants, they have a return type of void. Right? If you want to call a function that takes 3 arguments and does not return anything, you can use this action. Right? And the same way it is for predicate as well. If I select predicate, for some reason that I have not understood, predicate does not take multiple arguments. It has only one generic parameter and it has exactly this return type of Boolean. Right? So predicate will always be used where you are going to use different conditions. And it takes only one argument or a function that takes only one parameters and return a Boolean. So these are delegates for you. Delegates are modern way or C# way of having function pointers. Function pointers are simply variables like any other variable. Integer would have memory location. Function pointer is also going to have memory location. Inside integer variable, we are going to save integer values. Inside function pointers, we are going to save an address. Now, with function pointers, that address is going to point inside the code segment. And because it is inside code segment, it can be executed. And to execute that, all we have to do is put parentheses around that variable name like this. So the variable name and then parentheses around it. And if it is taking arguments, you can pass those many arguments, sometimes 2, sometimes 1. And then it is going to go and execute whatever function we assign to it. So just to complete, give you a different picture, let's create another function called s0, and it is going to return true if it is 0. So I'm going to call this function, and if I hit Control F5 now, because it is 10, it is not going to match and it's going to return false. But this time, just by changing the variable, we have started pointing to a different function altogether without the function ever getting called. This thing is going to come in extremely handy when we work on more complex programs in the coming sections. I know this is getting complicated, but let me go ahead and create something even if this is like complex, I'm going to create something even more complex. So we see that the add function that we had written somewhere. Okay, the add function is taking 2 parameters, right? This is regular functions. There is a concept called higher order function. So a higher order function is not going to return, say, a void or an integer. It is going to return a function or action itself. So I'm going to attempt that here, and it is going to look a little bit like this. So the return type itself is going to be func, and the func is going to take 1 input and it is going to have 1 output, and I'm going to call it higher order add. And it is going to take a parameter of itself, and I'm going to call it x. Inside this function, I'm going to write a return statement. And then this return statement would be x. Okay, give me 1 minute. Okay. Okay, I am kind of forgetting the syntax. So I don't know where the add operation is going to get executed. Give me 1 minute. All right, I am kind of forgetting the syntax, but then the way we're going to call the higher order add function is we are not going to pass two parameters that are comma separated. We are going to call this function, and then this part of the function is going to return another function, and that function is going to take the next argument. And through this argument, we are going to get our final result. I got a little confused in the syntax. This is how it is going to get called. And the advantage of that is that you can add as many parameters to this as you want. So the higher order function is going to return another function that takes a parameter, and the syntax is getting a little tricky for me. I don't know if it is also going to return this or what. Something complicated about this. I just got confused in the syntax. But then the way we were returning integer from the multiply function or boolean from the is zero is not zero function, it is also possible for us to return a delegate itself. So a function that returns a delegate is called a higher order function. And in a similar way, let me show you another example that I can probably pull a little easily. The way we were passing parameter to add function, we can also pass the object of delegate itself. So if I write a function called compare, let's start with something simple. I'm going to pass it to values 10, 20, and then the result is going to be available over here. I'm going to call it equals. I'm going to call it is equal. Because it is not defined, it is complaining right now. So I'm going to define is equal here. It is going to take two integer parameters, integer x and y, and it is going to return if x and y are equal, right? With this, we have kind of logged it to compare for equality already, right? Let me go ahead and change this name to is I'm not going to call it is equal. I'm going to call it matches condition, right? I couldn't think of a better name. But then we don't want to always compare for equality. Sometimes you want to say that our condition is that they should be equal. Our condition is that they should not be equal. And then when we have that kind of requirement, we are not going to compare it over here. We are going to compare it in some other function like bool equal. And for equality, we are going to define integer x and y and return x equal to y over here. And then if we want to check for not equal, we're going to define not equal function and we're going to pass it over here like this. But with a delegate, the delegate for this is going to look like func, and first two arguments are integer and the return type is boolean. So this function now can point to equal and not equal, and then I'm going to call it say condition. If I set condition to equal, it is going to point to not uh, not without the parentheses, right? Now what I would want to do is I'm going to assign a result to a function that give me result, something like this, and pass condition to this. Let's go ahead and define that function. So that function is not taking integers, right? It is taking a function. And then now I can call this condition over here like this. And I can have two variables, integer x equal to 10, integer y equal to 20. And I can change this to Boolean once again and pass x and y over here and hit the return button and return the result. So depending on how we want to compare 10 and 20, if you want to compare it for equality, we're going to set condition from the outside to equal. And if you want to compare it to not equal, we are going to modify this variable here to not equal. So essentially, this function, it only has the values, but then it doesn't know how to compare those two values. And the comparison has kind of taken away from him. And we are like, at runtime, we are going to tell you how we want to compare these two values. Okay, so sometimes we want to check for equality, sometimes we want to check for an inequality. So if I set this to not, okay, it should be not equal, right? Let's just go ahead and print the result. And we're going to hit F5. So x and y, it's comparing match condition. Okay, let's delete this. All right, so it is returning false first and true later because probably there's some other code that is getting executed. So I'm going to comment this predicate code out. What I've done is I've defined a variable condition, and this variable is going to point to functions. Now that function is going to be returning a Boolean and taking two integer values, but we are not going to use this condition directly. We're going to pass this func or this variable to another function, and that function is going to use this condition. So this function does not know which implementation is going to get called, if it is the equal implementation or not equal implementation. It is at the runtime based on the value that we are assigning to this delegate that this function is going to change its behavior. So when we set it to not equal and try to compare 10 and 20, it gives true because they are not equal. But then the flow is kind of tricky. We assign a delegate with not equal. We call this function. This function creates these variables, and it says that whatever function this condition is pointing to, just go to that function, perform whatever operation you have, and then you come back with the result. I'm going to return that result. This thing become extremely handy when we want to take away part of the functionality from the function itself. All right. And that's where delegates and function pointer become extremely useful. At runtime, you can change the way a particular function behaves. So in the last run, this function returned a true to us. But then if we run it this time, it is going to return false. So it's the same function that we are calling multiple times, and we are seeing different behavior because we are assigning different value to this function. Right. There are advanced examples of this that we are going to see when we see LINQ query in the coming sections. And we're going to talk about collections and other C# language features. But then delegates is a function pointer, and it's going to execute whatever function is getting assigned to it. Right. And higher order functions, they accept a function inside them. Right. So with that, we have reached the end of time today for today. Let's go ahead and end our session.